Broadcast is now starting. All attendees are in listen-only mode.
Thank you very much, everyone, for joining today's demo session on how Talon's intelligent file caching technology streamlines distributed IT resources and eliminates branch office backups. We'll wait a couple of more minutes for the attendees to join. Yeah, we can still see that there's some individuals joining the session, so give it 2 more minutes and then we'll get started. Yeah, let's give it 1 more minute and we'll get going. Yeah, let's get started. Thank you, everyone, for joining today's session. We're going to host a demo on how Talon's intelligent file caching technology streamlines distributed IT resources and eliminate branch office backups. There's more meat to the bone as we go through this session. This is the final session in our fall webinar series. Our previous webinars in September and October are available on our website. But in this webinar, we would like to share you some ideas on how you can drastically reduce cost and complexity associated with a distributed storage environment. Leveraging the Talon FAST software fabric, its intelligent file caching technology and how it integrates within your environments, whether that's on-premise data center storage, hybrid cloud storage, or leveraging public cloud storage to move your unstructured data workloads. Again, we will record this session today. Questions should be posted in the questions section, and we'll actually pick them up at the end of this session. So my name is Jaap van Duijvenbode. I'm product director for Talon. My main responsibilities are product strategy. I'm working with the largest enterprise accounts and our customers to help them solve the challenges around distributed storage and utilizing our technology. With me today is Michael Fiorenza, our lead solutions engineer in the Northeast. Mike?
Hi, Everybody, this is Mike Fiorenza, Solutions Engineer, like Jaap had said. I'm very excited to be here co-host and presenting Talon FAST and showing how we can help streamline those IT resources of user collaboration at the branch.
Great. Thanks, Mike. So briefly recapping, who's Talon? We're a software company founded in 2010, and we're headquartered out of the U.S. in Mount Laurel, New Jersey. And we have offices all over the globe where we help enterprises solve the inherent challenge around distributed storage and managing branch office storage. So we deliver software-defined solutions that helps to streamline the way that you're managing your unstructured data and your journey towards a centralized and consolidated data center storage infrastructure. We have approximately 350 plus customers globally, varying from 5 to 10 locations, up to hundreds of branch office locations where users need access to centralized data. We are now deployed at more than 10,000 branch offices globally where users are benefiting from a high-performance experience when it comes to accessing their files. Some of the key accounts, as you can see on this slide, that we work with are companies like Lego, Sweco, a large engineering construction firm out of Sweden, Vistaprint, the guys that obviously deliver the free business cards, United Technologies, and WSP. This is just a snapshot of our customers that have embraced the Talon FAST technology to centralize and consolidate their unstructured data. Some of the key business verticals that we've been focusing on over the years is AEC, architectural engineering construction, design and manufacturing, research, energy and offshore, healthcare, but also financial services. Now, enough about us. What we're going to talk about today is the Talon FAST software. We're going to talk about various deployment methodologies, and we're going to actually do a demonstration of deploying a file server infrastructure in the Azure cloud and creating centralized file shares that are managed, backed, and secured centrally. So Mike's going to show us how to configure the Talon FAST core instance, which enables the FAST fabric, and then subsequently how to deploy our software at the branch offices to leverage and benefit from the file caching technology, and how to present those file shares into your end user community so that they can actually start to collaborate on a global scale. Eventually, we'll talk a little bit more about what we've been able to accomplish and how that aligns with a typical perfect world scenario that our customers have kind of identified as the best of breed approaches when it comes to managing unstructured data workloads. And we're talking not only about just terabytes worth of storage. We're talking about managing hundreds of terabytes or petabytes worth of storage and potentially distributing that storage out to hundreds of branch offices. Subsequently, we'll open up for Q&A. So just recapping, based on our previous session, what do? We're a software-based solution, and we help enable enterprises to centralize file storage in what we call a single set of data. Our technology runs on Windows Server and essentially creates an intelligent file cache for branch office environments. As a result, we're only caching what's actively needed at those branch office locations, and therefore eliminating complexity around storage, infrastructure, and eliminating backups at the branch. So you're drastically reducing the storage footprint throughout your distributed enterprise. The closer the data gets to your user, the more performant it gets, and the more focused it gets on their workflow and the way that they're dealing with their unstructured data. As a result of being able to centralize and consolidate all of your file servers, NAS infrastructure, local storage in your branch offices, you can also instantly deliver enterprise global file sharing collaboration with the benefit of things like distributed file locking and full integration in the SMB and CIFS stack of services presented by Microsoft Windows file sharing. As our technology overcomes challenges around latency and low bandwidth scenarios, we are able to stream and compress the data and the delta differences over the wide area network, which subsequently delivers a high performance experience as all of your geographically distributed locations. Just as a result, a lot of our customers, they've been able to drastically reduce the storage footprint, but also been able to cut the storage cost associated with their distributed enterprise. Now, before we jump into the demo, Talon FAST runs on Windows Server, like I said. It fully integrates within your Microsoft ecosystem. So if you like managing your servers and your infrastructure through Hyper-V, through PowerShell, our software transparently fits on that architecture. It coexists with Active Directory domain services, additional services that you may need at your branch offices, such as DNS, DHCP, print services, as well as software distribution through SCCM. It all ties together into this single consolidated branch office virtual appliance template. Our software is flexible. As you can see in the following deployment methodologies, we're storage agnostic. We can work with any data center, storage provider, or cloud storage provider that you want to utilize. We're only caching what's needed at the branch, which means if you have 500 terabytes worth of data centrally, you may only need 500 gigabytes at the branch office to present the active data set to the users that are working on these traditional file shares. Our caching is zero touch. It's a self-managing cache mechanism that kind of ages, as it ages over time, cleans up the least recently used out of the cache to allow for new data to be cached and provisioned in that branch office. So you don't have to worry about adding storage in your distributed offices. It's highly performant. The software actually uses compression mechanisms. It uses the streaming of data between what we call the edge in the branch office and the core at the data center by eliminating the SMB and CIFS protocol and the inherent chattiness of those protocols of the wide area network. Therefore, drastically reducing the data over the wide area network, but also improving the experience for the end user to give them the idea as they are working on a local file server, but on a global scale. And finally, our software is consistent. Everything we do is in real time. We don't care about metadata or replication or exchanging information between branch offices. Our solution is designed to scale and is designed to be consistent so that everyone can see all the latest and greatest data in real time in their distributed branch offices and benefit from things like distributed file locking for applications that require strict consistency. And Mike will demo shortly what that looks like. So a couple of different deployment methodologies. I'll go quickly. We're storage agnostic solution. So by deploying our software, we're overlaying your existing or your future hybrid cloud, public cloud, or on-premise data center storage infrastructure with what we call the FAST fabric. And the FAST fabric runs on Windows Server and mounts to your corporate file shares and extends those file shares into your distributed file locations where the caching takes place. The fabric is also responsible for streaming and compression between your data center and your edge. So it's actually acting as a traffic cop between your existing centralized storage footprint and your branch office users. Subsequently, on the right-hand side, you can see all of these different vendors that we work with, that we've partnered with. We have validated reference architectures. You can download some of the reference architectures in this section in the GoToWebinar control panel. And we tightly integrate and validate with these storage vendors. So a couple of ideas here, and then we go into the demo in a minute. If you look at an on-premise deployment methodology, on the right-hand side, you see your data center. That's where you provision your volumes, your lunge, your iSCSI targets. You provision your CIFS SMB shares, whether that's through a file server cluster or through a NAS interface. For example, NetApp utilizes their own CIFS SMB interface. Our FAST service that is deployed on Windows Server mounts to that centralized data and extends those file shares into the distributed offices, in this case in Amsterdam and Paris. The model doesn't change if you change the way that you're managing your data. If you are a NetApp customer and want to benefit from NetApp OnTap Cloud for the purpose of business continuity and disaster recovery, snapshots, backups, all kinds of cool stuff, you can transparently integrate our software with that platform to facilitate for your data storage needs and your backup requirements and your business continuity requirements. In this example today, we're going to talk about a plain vanilla installation deployment leveraging Azure Disk. And we're actually deploying a file server in the cloud, and we're mounting and aggregating multiple Azure disks to present a large volume set and present multiple file shares on top of that to extend into the distributed offices. In terms of transport, our software enables and leverages SSL encryption between the edge and the core. So you can either use your existing MPLS or VPN infrastructure, but now you can also use the public internet as a transport, which is great. Depending on the requirements that you have from a data center or public cloud storage perspective, we can integrate in any type of solution or in any type of scenario. So today, for the demo, what are we going to do? We're going to deploy a file server in the Azure cloud and create some file shares. We're going to deploy and configure a core instance, which enables the fast fabric. Subsequently, we'll deploy the 2 edge instances in 2 separate sites. We looked at Amsterdam and Paris shortly. And then we're going to show what the fast virtual file share presents you, how to map that through a direct drive mapping, or how to embed that within a DFS namespace that enables a global namespace for your enterprise. Subsequently, we're also going to demonstrate the end user experience. What does it mean to work on a centralized set of data from a user perspective? What is a cold file? What is a warm file? And how do you benefit from the caching technology in those sites? So with that said, obviously, I'm going to hand this over to Mike, who's going to take you through this process of deploying this file server in Azure and actually extending that centralized data set through the fast fabric to the branch offices. So Mike, the floor is yours.
Excellent. Thank you so much, Jaap. So, hey everybody, this is Mike Fiorenza again. What we've done here is, like Jaap had mentioned, we've gone ahead and created a Windows Server 2016 instance in Azure. We've gone through the basic server configuration, joined it to the domain, set up the networking, and what we've gone ahead and done is actually created a file share on here called Talon Share. And we're going to use this as the authoritative data set. Within this share, we've created a couple of folders. We've applied our typical ACL permissions to those and staged some data in here. And you can see within the central data directory within that share, we have some office documents that are going to be the authoritative data source for our branch offices. We've also brought up a Talon core instance. This is a separate Windows Server instance, again in Azure, that's sitting next to the backend file server. And this is going to mount to the backend file server. It's going to expose those authoritative shares. You can see over here on the right-hand side, we haven't done any of the configuration yet, as that's what we're going to get into in a minute. With the core having been deployed, we then need to connect, naturally, our branch office instances. And what we've done out at the branch offices is we've actually gone ahead and deployed these Windows Server instances, and we've configured 2 what we call edge instances. So the edges are really going to be the point where users are going to access the Talon virtual file share in the intelligent file cache. We're going to get to that in just a minute or two. But I want to take a step back and talk about the actual core configuration. So to begin the process, we're going to go into the core instance, and we're going to start the process by first applying what we call a service account. And this service account is going to act on behalf of the users. Basically, it's a domain account which is applied to the share permissions within the backend file server. We've already gone ahead and done that. And we're going to apply it here to the core instance to provide the traversal and file lock and lease management on the user's behalf. So we're simply adding the credentials here and confirming them. And once we have this piece done, we're pretty much halfway through a basic core configuration. The next thing that we naturally need to do is point this to a backend file server to expose those file shares. So over on the left-hand side, we have a series of options, the second of which is backend file servers. And for this example, because we're using Azure Disk, we're using a generic Windows file server, we're going to have this set as a generic SMB server, and we're just going to enter the NetBIOS name of that backend. Now, the backend file server can also be a direct mount to Azure Files, or it can be a DAS or iSCSI mount. So you really have the options there, the flexibility to choose different backend storage platforms. Now, one thing that's very flexible and scalable when we talk about our core instance and what we can mount to, this can create a one-to-many type of deployment. Within this core instance, you can mount this to multiple backend file servers. You can have multiple cores in different data centers with different backend file servers, and the users will be able to basically aggregate all of this data pathing into a single logical namespace. And this can be, again, like Jaap had mentioned, a UNC map drive, or it can be wrapped up into a DFS namespace for a global unified means of access. And that's just something we'll take a brief look at here in a minute.
Yeah, and I think one thing that's really cool, in addition to what you're saying, Mike, is obviously we honor all of the authentication and authorization principles. Let's say your NTFS permissions on your existing backend storage infrastructure. We don't change anything in that sense. We transparently extend that into the branch offices. So if you have managed your files and your folder permissions already, there's no additional exercise required to present that in a distributed fashion as well. So some of the advanced options you can see on the left-hand side, we will talk about later onwards. But there's a whole bunch of options for you to kind of separate access from specific file shares into distributed offices, or to use things like pre-population, which helps you to pre-populate active data sets to distributed branch offices, meaning that you may work on an active project. I want to pre-pop all of the data associated with that project in specific sites as those users are heavily collaborating in real time globally on those projects. Pre-population is really an awesome tool to use when it comes to managing and pre-staging your caches with that information. Now, let's go back to deploying the fast edge instances. Mike, take it away.
Thank you. So now that we have the core set up, we're going to configure the edge. Actually, the two edge instances. We've gone ahead and installed the Talon software, configured the Windows servers, and actually applied the license to this. What we're going to do from a basic standpoint is we're going to create a fast fabric ID, which is just an indicator within the UNC of the virtual file share that Talon creates of where the data center is. In this case, it's Azure. We're simply going to then point this edge instance to the core, which will then subsequently open up the access to the backend file server. In this case, that Azure disk set of file shares that we have staged. So at a basic level, this is all you need to do from a branch office edge perspective, is simply point this to the core to associate it to whatever backend file servers, whatever backend shares it's presenting. And we're actually going to go ahead and do this same process on the second edge. And you can see everything looks exactly the same. We have that Windows server, it's been licensed. We're adding the same fast fabric ID to indicate where the data center is, and we're pointing it to the same core. So now these two edges with their connection to Azure, to that data center core, to the backend file server, these are now ready for branch office users to mount their map drives, to integrate this into a DFS namespace. This opens up the access to that authoritative data set for them to start working on and collaborating on that central set of data. So we can start talking about the virtual file share, how users interact with it, how they get to it. So this first example, we're just going to map a drive. And you can see all we're doing is we are mapping a drive to the local Talon edge instance in the first branch office, and we're pointing it to the fast data virtual file share. And again, this is what Talon at the branch office will open up to the branch office users for them to get to that central set of data. And again, this is something that's immediately familiar and transparent and non-disruptive to users, their workflows, and their applications. You know, if they're used to seeing the S drive for a particular set of projects or files, you know, it's going to be the S drive with Talon in the picture. And you can see as we navigate through this, we have that fast fabric ID that we called Azure. We have access to the backend file server in Azure, and then access to the share, and then those data sets that we had provisioned earlier. And you can see that we can see all of these files. for access based on our ACLs. Now, one thing that you may note on some of these file icons, there's a small gray X indicator, and that's a visual indicator to the user that the data that they're looking at is available in the data center, but has not yet been cached. And this is a key piece of the user experience and education. They understand when they see this icon that this file, when they open it, they're calling on it for the first time. This is what we call a cold pull. So they're getting the entirety of the file compressed and streamed from the data center to their edge. And once it's written there, they are effectively only sending changes back and forth across the wide area network. That gray X will disappear, and we're going to see that happen later once a file has been accessed and cached at that site. So the experience between a traditional UNC map drive and a DFS namespace when it comes to accessing files doesn't really change. What does change for them is how it integrates, how it's presented. With a DFS namespace in place, obviously you're leveraging your Active Directory sites and services to basically say users in this particular site are accessing data in this particular way. And you can see in this example here that we've created a DFS namespace. We've added 2 folder targets, one of which is the native path up to Azure to that backend file server. And then we've created within our Active Directory sites and services a secondary site for our branch office, our second branch office. And so what this is doing is this is basically pointing based on the network location. This is pointing users through the Talon instance to the data set. So the user doesn't need to worry about, am I in the right site? Am I connected to the right edge server? DFS using sites and services will automatically take care of that pathing for them. So again, the key takeaway here is that this makes it seamless. This makes it universal for how users are getting to their data, how they see it, and how they interact with it. If they DFS namespace already, then nothing changes to them. The only thing that they may notice different, again, is that small gray X where they will understand what that means. So you can see here now, we're on the second user workstation in the second branch office, and we're simply going to that DFS namespace that we've created. And through this, we can see within the DFS properties that, in fact, we are being pointed to the correct location. We're being pointed to the fast virtual file share. We're being pointed to the data center, to the authoritative data through the local edge instance. When we open the folder, we can see that we have the same access through DFS as we did in the first branch office using a drive mapping. So really, the options are there for how you would like to present this central data set to your branch office users.
Yeah, so you mentioned one thing, Mike, in terms of being able to present data in the branch offices using the local virtual file share that is part of that specific site. It's key to have your Active Directory infrastructure in order, because obviously DFS uses a combination of Active Directory sites and services and kind of broadcasts that information out through AD to the clients and the client's partition knowledge table. And the client will actually decide when it queries the namespace server to say, hey, I need to connect to my local Talon FAST instance, the virtual file share, to access that centralized data. And the nice thing about this model is obviously you can design a hub and spoke type of model where every branch office has their own edge instance, but you can also build in redundancy. So if your local edge instance fails, as you apply a last among all targets policy to your native target, being the file server in the cloud in this case, if your local edge instance fails for whatever reason, your end users, they can still continue working on that centralized data without compromising data integrity. So that's really cool. So one of the things that we want to show you as well today is kind of demonstrate the end user experience when it comes to not only browsing through folder structures, seeing the difference between cold and warm files, but also show you the benefits of our streaming, compression, as well as distributed file locking.
Exactly. And so what we've done here is we've set up two branch office edge users. On the left, we have a basic branch office employee. User count is rather limited in terms of access. And on the right-hand side, on the second client in the second branch office, I have an administrator account with elevated privileges to data sets. So back to the first branch office, we are using the drive mapping that we created earlier. We're going into the Talon share, and we're going to try to access this confidential folder. And you can see I right away get a message that this account does not have the access to this folder. And that's based on the ACL that I've set in the data center. Now, if I go back to my second branch office, to my admin account, I can access this confidential folder because my ACLs in the data center allow for that. And I can open and edit and save this confidential document. Now, again, the key point here is that these are all your typical ACLs that you're configuring on the authoritative data set in the data center. There's no proprietary security overlay or authentication mechanism that Talon is introducing here. You know, if you're setting the ACLs in your data center, that is where they will apply, and that's where they'll be propagated from out to the branch offices. So now that we've gone ahead and checked to make sure that our ACLs, that our permissioning was working, we can actually take a look and see what the data modification process and file locking looks like from the end user perspective. So I'm going to go back up a set of folders, and I'm going to go into the central data share. And I'm going to open a test file here. And you can see I have this gray X. This, again, is going to be a cold pull. So I'm going to double click this. This is now opening the session between my branch office edge and the data center core. And it's compressing and streaming the file out to my edge, updating the cache, and serving me the file from there. So here I have the file open. I have it cached locally, and I'm going to go ahead and just make a quick edit into this file. Now that I have that change in there, I'm going to go ahead and save it. This is saving to my local cache. And Talon FAST, the underlying software, is taking care of the delta differencing, the compression and streaming, and updating the backend file server. So now my local edge instance, as you can see, is up to date. The data center has received the latest and greatest changes. And I'm going to jump back to my first branch office user who has access to the same file. Now, this user hasn't seen this file before. We know that a change has occurred from the second branch office. So I'm going to go ahead and double click this file here. This is going through the same process where it's going to do the cold pull from the data center, from the authoritative copy. It's going to pull it down and cache it locally, and then serve me the file from the local cache. We can see that the change that I made in my second branch office from my second admin account have been added to this file, and I can see the latest and greatest based on what's in the data center. So let's say this has now become a collaborative project. I'm going to go ahead and make another change here. And what I'm going to do is I'm going to go ahead and save and commit this change to my local edge instance. Now again, Talon FAST is taking care of the delta differencing and sending those deltas back to the data center. So the data center, of course, now is up to date. It has the latest and greatest copy of the file. But you'll note what I'm doing here is I'm leaving this file open. I'm maintaining data consistency by keeping a file lock on this file. My branch user 1 is still working. There are additional changes that need to be made. So what I'm going to do is I'm going to just quickly jump back to my second account. I'm going to open the file again. At this point, I'm opening my locally cached copy. I'm getting just the changes from the data center based on what's been updated, and I'm getting a file lock message. You can see branch user 1 has this file in use. I'm going to go ahead and request a notification for when it becomes available. In doing so, I'm putting myself in the queue to wait for that file to open, but I can see, even in a read-only state, what changes have been made from the first branch office. The bolded second line there, I see that is the latest and greatest in the authoritative copy in the data center. Now, if I go back to my first branch office user, I'm going to finish making these changes, and I'm going to save and close the application. So this is going to do the final delta differencing, write these changes back to the data center, and end my session. Once the final write has happened and the consistency checking through Talon is complete, we will then drop the file lock in the data center. So now everything's been updated, the file is available for use, and we can jump back to my second user workstation, to my admin account. And we can see that once we get the notice that this file lock has been dropped, we are now able to take a file lock and merge the changes based on what the first user has done and get the entirely updated copy of the file in our cache, and we're able to continue working on this. So this gives users the feeling and the expectation with the distributed file locking mechanism, with the intelligent file caching, keeping their active data sets close. This gives them the sense that they're all working in the same location on the same local file server. It's that kind of experience that they would expect to have, as if they were all in the same place.
That's great. Thank you, Mike. And obviously this doesn't only apply to your typical Word documents. This also applies to some of the most complex engineering applications where you may have multiple users working on a central model at the same time, performing work sharing and borrowing specific elements of a model. And this goes a long way because the nice thing about the fact that our software overlays on Windows Server and all of the semantics around, the SMB protocol and Windows file sharing in general, it adheres to all of those principles, all of the different versions of SMB, all of the different dialects. Whether we need to speak to a central NetApp infrastructure, to a Windows server, or to a third-party, hybrid cloud storage device, all of these semantics will be maintained throughout the process of presenting that centralized data. So just to recap on what we just have seen, and this is just scratching the surface on what this could mean for you in terms of managing a distributed enterprise. We'll touch upon that a little bit later. There's a lot of things you can accomplish when it comes to scale. Whether you have hundreds of branch offices, whether you have petabytes worth of storage, the same semantics will apply because the model is based on caching and central data management and managing that single set of data on a centralized storage platform. So what have we been able to accomplish now? We centralized and consolidated an unstructured data environment into Azure in this case. Could be on-premise as well. Now, we're talking about a couple of file shares with a bunch of data here. But if you're talking about managing multiple terabytes of storage, you need to have a solution to migrate that data effectively as well. We help our customers to migrate data from their distributed branch offices into that single set of data at the data center, either through the FAST fabric or through online or offline data migration tools. We deployed a FAST core instance. As you could see, we deployed a Windows Server instance centrally, mounted to the central backend file server, and created the fabric. And by creating the fabric or introducing the fabric, you present your centralized file shares that are mounted through SMB CIFS or optionally through a direct attached storage interface such as iSCSI or even Azure Files, and extend that into the branch offices. And we deploy 2 edge instances in each branch office, Amsterdam and Paris, where you could see by either accessing data through a drive mapping or through a DFS namespace that end user experience is optimal, it's transparent, and it's highly performant and consistent. So in a way, you're creating this idea of a global file sharing collaborative environment, and at the same time, you're streamlining the cost and complexity with your branch office storage environment because you're only caching the active data sets. Now, as part of these results, and we can talk a little bit more about integration with a SCOM management pack for central management. We can talk about utilizing PowerShell scripting to deploy or configure your core or edge instances, the provisioning of folder structure centrally through automation There's a lot of things you can do and tie the Talon FAST software into, whether that's your business workflows, your processes, or whether that's your requirements around how you manage your storage. All of this basically comes back into this idea of a perfect world scenario where your unstructured data is centralized, secured. It's easy to scale out from a capacity as well as from a branch office perspective, whether you have 10 branch offices or 500 branch offices, whether you have 3 users at a branch office or hundreds of users. It guarantees data consistency, and it provides a software-defined approach that gives you the flexibility to deploy this solution in conjunction with your storage platforms on commodity hardware or on VMware or Hyper-V hypervisor platforms. That gives you a lot of flexibility in that sense. And at last, you've seen just that, obviously file locking is a key component when it comes to working globally and working collaboratively on file sets. And that's something that we touched upon as well. So why is this streamlined? Like I said, we're drastically reducing the cost and complexity associated with the branch office footprint. We leverage your existing storage infrastructure at the backend at your backend data center or in hybrid cloud or public cloud. And as a result of centralization and consolidation of your data, we're eliminating branch office backups. So you're able to manage all of your data centrally, protect and secure all of your data centrally, and you don't have to worry about those islands of data that gives you the headaches of managing data management, security, et cetera, et cetera. So that kind of wraps up today's demo session. I would like to open it up for questions here. And there's one question that I just saw coming in. Let me see why this thing is. So let's see. There's one question here. Is how does the intelligent file cache work? Well, obviously, the cache itself will grow over time, which means that if you've provisioned a terabyte worth of storage centrally, well, you provisioned a 1 terabyte of storage in the cache, obviously over time that utilization of that volume will grow. As soon as it hits 80% of the volume being utilized, we will schedule a purging process to be kicked off at night to remove the least recently used data from the cache to allow for new data to be seeded into the cache transparently. So you don't have to worry about adding storage. The purging and cleaning process will take care of itself, and will actually send you a report when that has been completed. How does the licensing work? It's another question. It's a site-based license. It's an annual subscription that we deliver, and it includes all support, maintenance, software updates, and web and phone support, so to say. So one more question. What about security? Well, that's a great question. There's a lot of things you can think about in terms of security. You can think about encryption. You can think about authentication, authorization. Like I said, from a baseline perspective, we fully integrate within all the semantics of Microsoft Windows Server and Active Directory, authentication, authorization, and things like permissions and NTFS permissions, ACLs. So once you've set up your folder structure centrally and secured them, all of those semantics will apply to your distributed branch office locations as well. In addition to that, you obviously can think about what about security in the way of data in transit. Our software allows for SHA-256 encryption between the edge and the core, which allows now customers to leverage the public internet as a transport mechanism as well. We typically work with our customers to leverage their existing MPLS or their site-to-site VPNs, which already provide security in the sense of data in transit. From a data at rest perspective, some of our customers, they had the requirement to encrypt what they call the cache instance. They could encrypt the fast data volume, or the D drive in this case, using BitLocker drive encryption, as well as having the ability to use TPM support to manage and maintain the keys associated with that encryption. So all in all, it transparently integrates with an end-to-end security strategy from a Microsoft perspective. If you have additional requirements, for example, for things like auditing, integration with third-party tools like Varonis, we can discuss the right approach for that scenario as well. So I think that wraps up our questions. If we have more questions coming in, feel free to send them over to info@talonstorage.com. Basically, we will respond back to you. We'll discuss your requirements. We can have an interactive session with you and your team to talk a little bit more about the specifics of your environment. And with that said, I want to wrap up this call. Thank you very much, Mike, for demoing the solution. Thanks, everyone, for joining today. More information can be found at www.talonstorage.com. And I would like to wish you all a great year's end and happy holidays, and we'll touch base in the next year. Thank you very much, everyone. Bye-bye.